Welcome back. Recall from our last lecture video that we talked about the scientific method as a knowledge acquisition system. We talked about the hallmarks of the scientific method, which were empiricism, intersubjectivity, explanation, and determinism. We discussed the difference between scientific method and common sense, and finally, we talked about the nature of scientific knowledge claims. Today, we're going to look at the role that concepts play in the scientific method, what exactly concepts are, the difference between a nominal and an operational definition and how they play into what a concept is and how we use it, the 4 requirements of a nominal definition, how we use concepts for classification, comparison, and quantification, and the criteria by which we would evaluate effective concepts. Concept formation is the first step towards treating a phenomenon not as unique and specific, but as instances of a more general class of phenomenon. Concepts essentially provide 2 key functions. They're used as tools in data gathering, or think of them as data containers, and they're used as the essential building blocks of theories. So what exactly are concepts? A concept is a universal descriptive word that refers directly or indirectly to something that we can observe. When we think about the difference between a universal descriptive and a particular, universals refer to the class of phenomenon. For example, advanced industrial democracies. The particular are the particular instances of that class. So as we think of advanced industrial democracies, we might think the United States, Canada, France, the United Kingdom, etc., as being particular instances of the class of phenomena that we called advanced industrial democracy. Thus, conceptualization allows us to see the particular as an example of something more general. It involves both a process of generalization and abstraction. Generalization occurs because when we classify phenomena according to the properties that they have in common, we're necessarily ignoring those properties that they do not share. For example, we might be thinking of advanced industrial democracies, Canada, the UK, France, the United States, sharing properties of democracy and certain levels of industrialization, but we're not thinking about the properties that they do not share. For example, language. In France and in UK, they typically speak French and English, so language is not part of our general classification. It's an abstraction because, of course, a concept is just a representation of a class of phenomena that we assign through giving something a label. Concepts, particularly in the social science world, do not exist. They're just labels. But a concept is just a word or a symbol that represents an idea. A concept, to be useful, will of course have empirical reference, meaning that it must refer to something that we can observe directly or indirectly. The link between a concept and its empirical reference is produced through both the nominal and operational definition. Every concept needs both a nominal and an operational definition. A nominal definition describes the properties of the phenomena that the concept is supposed to represent. For example, think of socioeconomic status. When we think of socioeconomic status, we're probably thinking of differences that we could observe in material well-being, affluence, status, etc. An operational definition identifies the specific indicators that will be used to represent the concept empirically. So again, with socioeconomic status, you can imagine that our operational definition might specify that we would want to observe income, education, and occupational status. The nominal definition provides a basic standard against which to judge the operational definition. Do the chosen indicators really correspond to the target concept? A nominal definition is neither true nor false, though it certainly may be more or less useful. There are 4 requirements that we would generally like to see of all of our nominal definitions. The first, clarity, suggests that all of our concepts must be clearly defined, otherwise we're compromising intersubjectivity. Second, precision. We need to define concepts precisely if they're to serve as data containers, and it must be clear what is to be included and what is to be excluded from each of the data containers. Third, we want non-circular definitions, which means that we don't want tautological definitions, i.e. defining a concept like dependency as a lack of autonomy. And finally, it's preferable that our Nominal definitions are stated in a positive way, meaning we should state the properties the concept represents, not what the concept lacks, as the number of properties that a concept lacks is infinite. So we want to add to our conceptual definition only those things that are actually represented by the concept. Once we've defined an effective concept, it'll be useful for three possible things. Concepts can be used for classification, which is the sorting of classes into categories. For example, regime types: democratic regimes, authoritarian regimes, mixed regimes. It can be used for comparison, which means the ordering of phenomena, indicating whether or not they have more or less of a given property. So with political stability, there are less stable regimes and more stable regimes. Finally, concepts can be used as a basis for quantification, which measures how much of a property is present. So if we think about voter turnout, a concept can map onto something that will establish for us the percentage of voter turnout in a given election. To evaluate a good concept, we need to ask ourselves whether it has both systematic import and empirical import. When we talk of empirical import, we're saying, is it possible to link our concepts to observable properties? If we can't use concepts as data containers. Concepts can be linked to observable properties in three ways. Directly, if the concept has a directly observable counterpart, for example, the Australian ballot. Does a country have a secret ballot system or not? Now, these tend to be fairly rare in political science. Less rare and far more common is indirectly via our operational definition, or how we've defined our concept. We cannot observe power, but if we can observe behaviors that indicate the exercise of power, for example, the number of troops that a country has, the size and scope of its trading relationships, the number of diplomatic missions it has abroad, the number of diplomats it sends abroad, etc., we might be able to operationalize how we would measure the concept of power. Thirdly, we could examine a concept via its relationship within a theory to concepts that are directly or indirectly observable. Again, this is very rare in political science, but an example from economics, marginal utility, has to be observed given the observation of utility. So, empirical import can be observed directly, indirectly, or via its relationship to concepts that are directly or indirectly observable. Systematic import says once we have our concepts, we must be able to relate these concepts to other concepts. Otherwise, they cannot serve as building blocks. Empirical import tells us whether we can use our concept as a data container. Systematic import tells us whether or not we can use it as a building block. So to recap, we've looked at concepts as an integral part of the scientific method. We've examined the role that nominal and operational definitions play in concept formation. We've examined the use, classification, comparison, and quantification of concepts, and we've evaluated different ways to determine how effectively we've developed our concepts. Next, we're going to move on to what's called operationalization, where we move from concepts to variables.